Okay, good morning students. This is a lab experiment which I am trying to explain about the working of stepper motor using LPC2148. Okay, so this is how the stepper motor look like, or this is how the stepper motor is being located inside your LPC2148. So the white color one, whatever we are seeing it here this from the stepper motor, the wire will be inserted here, and this gets connected to this stepper motor which is inside my 2148 LPC2148. Okay, only this particular part, only this part I am trying to show it to you how the stepper motor is being located in LPC2148. So I told you there are four wires from my stepper motor, which we call it as windings: winding A, winding B, winding C, and winding D. So there are four wires. Each wire I call it as a winding, and it has been connected to the port number of P1, 24, 25, 26, and 27. So what is this port number? I will show it to you here. So in LPC2148, if I could see here, there are two ports in LPC2148. One is port 0, another one is port 1. Okay. So both the ports, port 0 and port 1, is of 32-bit and which is of 64 pins of the microcontroller. Each port we have it as a 32-bit and which is being provided by 64 pins of microcontroller. Each port is having a 64 pins of microcontroller. So example, how it is being named, the naming convention of these ports is, example, if I just say P0.1, this P0.1, here 1 indicates the pin number, P0 indicates the port number, port 0, pin number 1 of this port 0. If I give P1.10, 10 pin which is of port 1, that is what it is trying to indicate, that is what is being represented in LPC2148. So the same thing I have written here, all the four windings whatever is being there from the stepper motor, which is being given to the port number 1 of pin number 24, 25, 26, and 27. So usually this is how it is getting connected. The stepper motor is getting connected to LPC2148 using these four port pins only: P124, P125, P126, and P127. Okay, so this is how internal structure of my stepper motor and LPC2148 works. Okay, so this is how the internal structure is. So this is my stepper motor. All these are my windings. Each one wire I call it as a winding, and this is my LPC2148. And this the stepper motor is connected to LPC2148 using these transistors. These are all called as transistor. Okay. This is my collector, this is my emitter, and this is my base. Okay, base is being connected to LPC2148 and this collector is collecting the data from stepper motor and giving it to my base. But initially the base is all equal to 0. So when the base is 0, this collector is open. When this collector is open, whatever the power supply that I give it to this stepper motor will be 0 only, because there is no connection that has been established. So there will be no power supply that is passing through this transistor. So but why I am giving this 12 volts here? Because the stepper motor cannot run with a voltage of 2.5 volts or 5 volts or 8 volts. So I have to have a voltage of 12 volts for the stepper motor to run. So I am giving it as 12 volts. So now this is how internally it is being connected. We no need to connect it in lab in this particular manner. I am just trying to explain it to you how this is going to get connected internally using the stepper motor and LPC2148 using this transistor. Okay, so now the motor can rotate in two directions. Either it could be in clockwise direction or it could be in anti-clockwise direction. Okay, so when it wants to rotate in anti-clockwise direction, what will happen? This base P1.24 will become high. So when this becomes high, this gets closed. When this is closed, the power supply will start running through this particular winding. When the power supply starts running through this particular winding, what will happen? This winding will start rotating it. Okay, so when this gets rotated by an angle of 1.8 degree, because all the windings should rotate, which is equal to 1 revolution. So 1 revolution is nothing but 360 degree divided by the degree what is being divided into each one of the windings, what is being taken in the stepper motor. So I have taken it as 1.8 degree. So 1 revolution is equal to 360 degree divided by 1.8 degree, which is equal to 200 steps or 200 rotations that will happen for this particular stepper motor. What is being shown here, this is how it works. All right, so now what will happen when this is rotated, this is high. After that, what will happen? This will become low and this next winding will become high. So so this will become this winding A will become 0 and this will become high. Okay, so now this will become low, this will become high, this will become low, and this will become high. So like that it will complete all its turn, again it come back from the beginning. So this is how the anti-clockwise direction of the stepper motor runs with respect to these windings and these transistor, how it is going to work. Okay, so this one revolution it will complete by all the four windings of A, B, C and D. Now, the same thing I do it for the clockwise direction also. But the difference in the clockwise and anti-clockwise direction is I will start from the other direction. There I started from 24. Now I am starting it from 27. 27, 26, 25 and 24. The same procedure has been applicable here, but I am doing it in the opposite direction. That is all the difference between clockwise and anti-clockwise direction. Now we'll see the working or the code, how are we going to write it for the stepper motor. So here as it is LPC2148, the header file what I'm using is LPC2148.h. Okay, so hash define clock one, the clock is clockwise direction, a clock is anti-clockwise direction. So to represent it is a clockwise or anti-clockwise direction, I am using two switch 1 and switch 2. If I press switch 1, it is clockwise direction. If I press switch 2, it will be anti-clockwise direction. P1.16 and P1.17 is nothing but the pin number with respect to port number. Switch 1 is being located in pin number 16 of port 1. Switch 2 is being located in pin number 17 of my port 1. Okay, when I press switch 1, this is being connected to this pin number. When I press yes to, this has been connected to this particular pin. Okay, so now when I press switch 1, that means it is a clockwise direction. That means that the 16th bit P1.16, the 16th bit will become 1. The rest all bit will become 0. Okay, when I press switch 2, this is anti-clockwise direction. So the 17th bit will become 1, the rest all bit will become 0. That is the difference to show whether it is a clockwise or anti-clockwise direction. Okay, so this is the delay function that I have written here. The 40,000 whatever we are trying to show it here, it is a count. Okay, the count value depends upon the user. Whatever we want, we can give it. But speed and count is inversely proportional to one another. If speed decreases, count increases. Count decreases, speed increases. Okay, so we have to give the count value in such a way that I could see the rotation of the stepper motor slowly. If I give a count very less number or very more number, that speed will become very fast. I cannot see the speed of the stepper motor at all, whether it is in clockwise direction or whether it is in anti-clockwise direction. That should not happen. So the count has to be given in that particular manner. Okay, so the next one, this is my main function. So IO dir is nothing but input output direction. IO CLR is nothing but input output clear. There is another pin also. PIN SEL means pin select. IO pin select. So these are all the terminologies that we are using it with respect to LPC 2148. Okay, so here input output direction means I am trying to make the direction here. So all these 24 to 27, the port number whatever is been given here, all are the output pins, and all these has to be clear. All these has to make low. Only then I can start from the beginning. When I make that as low, only then I can give as a clockwise or anti-clockwise direction. So I am trying to initialize this in the beginning to make out whether it is an output pin or input pin, or whether I have to make it as low or high for the beginning of my clockwise or anti-clockwise direction of the stepper motor to run. Okay, now in this logic, what we can see here is, now assume the clock I am doing clockwise direction, that will be 1, anti-clockwise direction, that will be 1, which is true. Now pin number 1 is being selected, but for anti-clockwise direction I have to select pin number 2, switch number 2, but I have selected switch number 1. Assume this is also true and this is also true, and this is your bitwise AND operation. When I do true and true bitwise AND operation, it is true. Not of true will become false. When it is false, it will not enter into this loop at all. Correct? So it will go to clockwise direction. So in clockwise direction, what will happen? So this is true. This is also true. True and true will become what? True and true will become true again. Not of true will become false. So this will not enter into this loop also. Okay, so none of the loop, if it enters means the stepper motor will not rotate. So what we have to do is, this is anti-clockwise direction, it is true. Now I have to select pin number or switch number 2 for anti-clockwise direction. So switch number 2, so this will become false now, this is not pin 1, this is false and this is true. False and true becomes what? It is false. Not of false will become true. So when it has become true, it will enter into this particular loop, anti-clockwise loop. Okay, input output pin 1, what will have, what it will show here is, this is my winding A, this is winding A, winding B, winding C, and winding D. So whenever I say it is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. So 2 to the power of 0 is 1, so it is 1 here, winding A. So when winding A becomes high, so what will happen? A will rotate. If I could see here, the A will rotate. In anti-clockwise direction, this will become 1. So A will rotate. Then with certain delay I have to give, because I have to see that rotation of that winding. Next, B will rotate, because B becomes high. This is the 2 to the power of 1. 2 to the power of 1, this becomes high. This next one is C becomes high, next one is D becomes high. When all these completes 1111 revolution, what will happen? 1.8, 1.8, 1.8, 1.8. So all these into 50 will give you 360 degree, which is nothing but my one revolution. For that reason, I have given this line. Okay, for I is equal to 0, I less than 50, I plus plus, because this is what I have done it here. So we have done it here. 1.8 into 50 is nothing but it's my one revolution completely will give you 200 steps of rotation that takes place with respect to anti-clockwise direction. The same thing if I do it for the clockwise direction, but I'll do it in the other way. Okay, because it starts from D, C, B, and A, because the diagram whatever I have shown in the earlier, so A, B, C, 24, 25, 26, 27 is anti-clockwise direction, 27, 26, 25, and 24 is my clockwise direction. So which will be my first pin which has to be high? It is winding D, which will make high. So which is D means it is 2 to the power of 3, which is nothing but my 8. So this will become high and gets rotated with certain delay. Next C will become high, rotate with certain delay, and B will become high, rotate with certain delay, and this A will become high with rotate with certain delay. And this again 1.8 into 50 will give you one revolution of rotation of this clockwise direction. So this is a code for anti-clockwise direction, which we do it in ABCD manner. This is a code for a clockwise direction, which we do it in DCBA manner. So this is the code for your stepper motor. So this is how the stepper motor works. So in your experiment, the lab experiment, the connections, whatever you do, you no need to do the connection in this particular manner. This is not the way. This is not is been required for you to do it. You will be having your LPC, you will be having your computer, you will be having your stepper motor. You just have to connect the wire from one to another. This is the internally how it is going to work. I have tried to explain it to you. Okay. So in one more video, we will show you the working of the stepper motor with the connections. How do we do it? Hope you have understood this. If you have any doubt, please let me know, so that we can clarify your doubts once again. Thank you.